Filtered shellcode, a program that just runs the code you give it. That seems kind of boring. All right, so we have a link here. I have loaded this link into Ghidra. All right, so what Ghidra shows me is I have main, and I have this execute function. So let's go back and look at main. What main's going to do is it's going to give code, we read it in, then we check to see if it's an odd length, and if so, we add 90, which is a no-op character, to the end. So that's going to make it an even length. Then we go into this execute, and what execute does is execute is going to go through and it's going to add a bunch of no-ops and a return to our shellcode. So let's kind of look at how that actually happens, and we can do that in GDB. All right, so I'm going to set a breakpoint, and the breakpoint I want is right before it calls execute, which is 804.85C9. 804.85C9. Now we'll run this, and I'm going to give it picoCTF because I know those are 1 byte instructions. All right, so here we are. We're about to call execute, and so we can look at, let's just look at 16 instructions at EAX. So there's my PQ nop nop RS nop nop T. So it's basically taking 2 bytes and then throwing in 2 nops, 2 bytes, 2 nops. All right, so let's see how annoying that is. We'll look here at some shellcode. Here is a 32-bit shellcode for Linux. It's 28 bytes long. Most of the instructions are 2 bytes or less. It's only these 2 pushes that are really going to be problematic for me because those are 5-byte instructions. It'll like slap some nops in there. I can pad this instruction by putting a nop right there, so that won't be an issue. But I really need to figure out how to push these 2 numbers. All right, so to push those 2 numbers, this website here gives me lots of ability to like look at how long an instruction might be. That comes in handy. Here I've actually got something similar going on. This is where I've actually put in the entire program. So I'm going to zero out EAX and ECX, push EAX, that came from the old program, and then that extra nop that I talked about. I'm going to zero out EAX again, put 68 in the low byte of ECX, that's what that CL means, the very low byte of ECX, add it to EAX, shift EAX left 8 places, put this byte in CX and add it, shift that 8 places, put 2F, add it, shift 8 places, put 2F in. And so then all of this here, you'll note each of these instructions is 2 bytes long, gives me the ability to push that 1 long constant. Then I need to re-zero out EAX, do the whole thing again, re-zero out EAX, and I can just copy the code that I had from here. So what we've done is I've then taken basically all of these bytes, which are going to basically do this code, but I've expanded this out, and I put those into a little Python program that's just going to print them out. I'm going to say Python filtered.py. I'll put that in a file called Bob. Now I can cat Bob, and then I'm going to read from the keyboard, and I'm going to send that to netcat, to mercury picoCTF.net, port 40525. So it's run by shellcode. I can say ls, cat flag, and that was fun. Actually, I don't know exactly how fun that was, but we have gotten ourselves the points.